next, please welcome Vaibhav Verdhan, Director of Advanced Analytics and leader at AstraZeneca. He's a seasoned data science professional with a rich experience spanning across geographies and domains, and a publisher author of books on machine learning and deep learning. And today he's here to discuss primary use cases of AI and computer vision for healthcare, which is really interesting, and the tools and technologies that are used, case studies, and the major challenges they're facing. And over to you, Vaibhav.
Welcome all. My name is Vaibhav Verdhan. I'm an advanced analytics leader with AstraZeneca UK, and welcome to the Data Science Salon, where we are today talking about machine learning extending computer vision in healthcare. A bit of background about myself. I'm a director at AstraZeneca in advanced analytics team in UK. Prior to that, I was in Ireland. I was working for Johnson & Johnson Vision Care as a principal data scientist. Prior to that, I was again in the UK only working for the consulting arms. So in my career, I have worked for retailers, telecom operators, utilities, pharma clients, manufacturing in advanced analytics, machine learning, and AI space. I love to contribute to the community. I am a regular speaker at conferences and webinars and seminars. I do like to teach students and senior folks on that. So please feel free to connect with me on LinkedIn. Okay, back to the discussion that we are going to have today. University of Central Florida, they did a study, they did a research, and they found that artificial intelligence algorithms are 95% accurate, whereas the humans they are 65% accurate in cancer detections. Okay, that's a way big difference over there. Globe Newswire in 2021 they said that the autonomous vehicle market is going to grow to $888 billion by 2028. And we do know that for autonomous autonomous vehicles, machine learning, AI, and computer vision they play a very significant role. From the Grandview research that was done last year in November, the CAGR is 7.6% from 2020 to 2027 for the computer vision market. And we know that, computer vision is making a change, is creating ripples across the globe, across multiple brands, across multiple domains, across multiple markets. Nothing new to us, right? So if I take a step back from there, what exactly is computer vision? In simple language, in simple layman's term, computer vision is the ability of the machines, of computers, to understand digital images or videos. That is the most simple definition of computer vision. And how is that possible? That is possible because each image is made up of pixels. Each pixel is made up of RGB values. In simplest terms, if I say that, we can represent each image into numbers. And why do we need that? We need that because our algorithms, our processors, our machines can understand numbers only. So if you look at the entire solution, images can be down into pixels, and pixels can be fed to the algorithms, to the processors, and then these algorithms they generate the intelligence around these digital images or videos. Videos is a step ahead from images, that is images plus audios on top of that. But in a nutshell, I would imagine that you would have understood the meaning of what is computer vision. It is indeed a very powerful solution. In manufacturing domain, on the screen you can on the slide you can see that using computer vision we can identify if there's a person there, if it is a chair, if it is a machine. In fact, there's a very famous use case being used for that is called digital twin, you know, that is also using some elements of machine learning. So computer vision is is allowing the manufacturing industry to take a leap ahead to and making it more secure, decreasing the number of accidents on the sites, and allowing the technicians on the line to improve their efficiency in healthcare. And we will discuss about the use cases in healthcare in detail. But at a high level, computer vision and AI, they are helping us in better detection of cells, of cancerous cells versus benign cells, in identification of joints or breaks in the bones, in drug discovery. And we have seen during pandemic that how AI is helping in automating the entire processes and making a difference in the life of the patients. In automobile, needless to say, we discussed the use case of autonomous driving. At the same time, to identify the pedestrians along with that, or there is a solution which is, in fact, that's an old solution of license plate recognition, which has been implemented in many parking spaces across the globe, where the license plates are read automatically by the machine. So for automobile sector, computer vision is helping the industry to create really intelligent automobiles. Security, needless to say, computer vision is able to identify the faces, the bodies, any danger, and security cameras, instead of simply recording the videos, they can identify a person who is unidentified for that household, or if there's any kind of a danger over there, or if they detect any kind of a weapon, of a knife, of a gun in their hands, and immediately the security alarms can can will go off, and the security forces will come to the place and save the day. So computer vision is very powerful in the traditional domains. At the same time, it is making its impact in the non-conventional domains too. So, like in pollution control, computer vision is able to detect the presence of oil spills and leaks, or dust bins, or if there is a lot of garbage in a certain area. So the the authorities or the cleaning bodies can focus on those areas, and it saves precious amount of time, and obviously it allows us to have a greener earth. For disaster management, in fact, it's a uh, very strong use case, because imagine that there is in a flood like situation where the resources are limited, the time is limited, and every second is precious. Where to focus, which area should the disaster management team, the rescue teams should go, and go and search for survivors. So over there, using computer vision, the presence of life can be detected using, let's say, drones, and then the security forces, the rescue teams, can go and search for survivors in those precise areas, thereby saving human lives. Retail, uh, you must have seen many use cases of scanning the barcodes and etc. They are the old use cases. Now using computer vision, the retailers can actually measure the emotions of a customer while they are picking up a product, or while they are trying to read its content, or they are trying that product just by just by paying around that. So the computer vision part for retailers is again is quite huge. In banking, I think banking is one of the most advanced consumer of computer vision. The processing of checks has been expedited. The signature verification, that has been made much more rigorous using computer vision and using AI. But today's session we are focusing on healthcare. So before going into healthcare, let's talk about a few tools and techniques of the available suits in the market. So OpenCV is one of the most commonly used library of packages, and a number of simple use cases can be generated or can be created using OpenCV. And you know There had like face detection or eye detection or detection of an object in a wider scheme of things that can be done using OpenCV. But OpenCV has some limitations, and that is why we have deep learning based networks generating better values in terms of accuracy and in terms of scalability. So TensorFlow and Keras, they are the most famous libraries because first of all they are open source also. So with the advent of TensorFlow and Keras, the use of computer vision using AI, it has really scaled up. We do have the players, the heavyweights with their own tools like IBM has Watson, Amazon has Amazon API, Google has AutoML Vision, and so on and so forth. But at a high level, I can safely say that TensorFlow and Keras are the most popular solutions, are the most popular libraries for generating deep neural networks for computer vision. The architectures are the most famous ones, or the I think the first architecture was LayNet. Then we have LXNet, VG16, Inception, ResNet, YOLO, SSD. Multiple architectures are being researched upon and created. A very important factor over here is that all these architectures can be used directly, using transfer learning. We'll cover that in detail also. Uh, but uh, but we need not create these neural network architectures from scratch. We can use the In fact, we do use the intelligence of these architectures to create our custom solutions. Okay, combined with the GPUs, with the processors that we have, computer vision and AI, they are really changing the landscape across multiple domains. So in healthcare, so let's take a few use cases for healthcare. So first of all, uh, the detection of cells, of let's say cancerous cells versus benign cells in any parts of the body, that is feasible using computer vision. If we want to detect any kind of clots or any kind of blockages in our heart or brains or arteries or veins, using computer vision we can detect those precise areas, and the doctors and the medical practitioners, they can focus on them. Bones and joints, if there's any kind uh, of breaking of bones over there, the level of the impact can be detected using computer vision. Now how does it happen, so we'll take a use case, and we will cover the end-to-end process for that. So it starts with defining the business objective. Okay, so let's combine two domains over here. Let's talk about uh, manufacturing, and let's take medical devices. Okay, and we say that we have a manufacturing company, and that manufacturing organization is manufacturing those medical devices. It can be it can be you know v- surgical equipments like like it can be any surgical equipment, or it can be um medical devices like or medical equipments, or it can be lenses, or it can be any kind of drugs. Now let's say if you want to identify that if there's any quality leakage for our our equipment, or on the drugs, or there's any kind of particle which should not be present over there. You can call it a foreign particle, an unwanted particle, which gets inside the solution, or which gets onto the medical equipment because of the manufacturing process, like a thread, or like a hair, which can be hazardous to health also. So if that is our use case, we would want to have an AI solution which can detect that foreign particle for us. Believe me, the biggest challenge that we are going to face is this part, the data discovery and data preparation part. Because for training our machine learning algorithms, we need to have enough representative data. And that data set is very difficult to collect. So we can create the the images, the raw images, using a paintbrush. So let me explain on that. So let's say you have so to train a machine learning model, you need good examples and bad examples. It will be very difficult to collect the bad examples. So what you can do, you can take the good examples, okay, and manually doctor them to create a few examples of bad representation, okay, and train the very first algorithm on that. Now that algorithm will be very crude. Its accuracy will not be 90%. It will be maybe 55%, 54%. But at least it will give you a starting point. And you use this algorithm and use it to collect more bad examples, or examples of images which are negative. And that's where, in that manner, you can increase your training set. Okay. So once your training set increases, then you will be in a very good shape to create the model, to create a meaningful model. Okay. So for image processing, image processing and image augmentation, it is not like to structure data where we do have a uh, lot of processes. But over here for images, we can do a lot of methods or a lot of tricks to augment the data, like creating of, like stretching it, or creating the mirror images, or rotating the images, or taking only a portion of images to enrich our training data. Machine learning algorithms, or the AI algorithms, perhaps the most uh, sought after part, or the most glamorous part for the entire solution. It will be which kinds of algorithms we can use. So I would so most of the algorithms for images are based on CNN. Okay, so I would suggest that you can start with maybe a few algorithms like a Linet, or an LXNet, or a VG16, and use that accuracy to benchmark. And perhaps an inception network or a ResNet might give you the best results. Now, when I say results in this case, in the example which we took over here for detecting the presence of a foreign particle in my medical device, for that you can uh, concentrate on recall of detecting the foreign particle. At the same time, you have to keep in mind that the the false positives might be as low as possible, because if your false positives are higher, you are throwing away good product, right? It might be a very good idea to use transfer learning over there. So what is transfer learning? Transfer learning, it allows us to use the pre-created networks, right? The networks which have already been trained. Like for example, we have all these networks, neural network architectures. So we can use these architectures which are already trained, We will freeze the very first layers of the network, and the last layers of the algorithm of the network will be trained. Okay, so let's say the original network was trained on cats versus dogs, right? So we will use the initial weights as is, whereas only the last layers of the network will be trained. Why is that possible? It is possible because the first layers of the CNN architecture, they concentrate on detecting the lower level features like edges or lines or curves, and that is true for all kinds of images. So whether you are detecting a cat or a car, you know, uh, the first layer of the network still holds true for you. Okay, so we can easily use transfer learning solutions to transfer learning solution to use the already trained networks. And finally, we will have the trained algorithm based on the threshold we set for our recall or for our false positive and everything. Creating a model is one part, whereas deploying it into the production environment is completely different ball game. So if data discovery was a big concern, the deployment will be a bigger challenge for you. So be ready in terms of infrastructure, in terms of your vision for model deployment, and how do you actually want to use it. Okay, there are some challenges that you will face in the industry. So first of all, having an effective and concise business problem is difficult. At the same time, an achievable business problem is quite difficult. So I it will be it might be futile, or it might be monstrous or brutal for me to have a solution which is having, let's say, 99.9999% recall and 0.0001% false positives. Okay, so having an effective business problem is the key. Like we discussed earlier, raw data or the availability of raw data to train your algorithm is the second biggest challenge you will face. So I did share a trick with you, but that trick might not be useful always. So you have to be creative to collect your raw data. At the same time, you have to be patient enough to iterate over versions and versions of algorithm. You cannot give it up that, okay, I do have only 50 images to train the algorithm. I cannot do anything. I understand it is not possible with 50 images to train the algorithm, but with time, that 50 will increase to 500, and that 500 will increase to 5,000, and then you might be in a better position to train the algorithms. Processing power, it is not feasible, it is not possible to train uh, an algorithm which has, let's say, 50,000 images. Each image is of 10 megabytes, and it will be very difficult, or in fact sometimes impossible, to train the algorithms on your CPUs. So you will need good quality machines, good quality GPUs to train the algorithms. And for that, the cloud-based infrastructure, it provides ready-made solutions which are scalable, which are accessible, and which are sometimes the most cheap solutions available also, right? So I would suggest you to use processing power provided by the cloud platforms over there. And finally, last but not the least, the availability of talent pool, it can create some problems for the business leaders, that whom to pick, or where is the correct set of data scientists and practitioners to to create that vision for the team, and to actually create those scalable, meaningful solutions using AI. Okay, but at the same time, I am I am hopeful that with the advent of artificial intelligence and computer vision, the healthcare field is going to generate great amount of insights for our healthcare professionals, for our physicians, for our nurses and doctors, who spend hours and days and weeks in making that difference in the lives of the patients. For all of us, it has to be really you know, it will be really beneficial if computer vision and AI can detect the disease early. The diagnosis can be much more correct, and hence few more lives can be saved. Few more lives can be saved at a much faster pace. So that is why the future is bright and full of hope for me. Thank you very much. All the very best to you, and we can take the questions now. Thank you.